Hi all, welcome to our channel Electromer. In this video, we are going to learn about Norton's theorem and the DC circuit theory. Norton's theorem. Norton's theorem states that any linear circuit containing several energy sources and resistances can be replaced by a single constant current generated in parallel with a single resistor. Norton's equivalent circuit. So if you want to use the Norton's theorem for a particular circuit, we have to split the circuit into two parts, which should have to contain several energy sources. That means batteries or something. So that should contain several energy sources and resistances. So that should be in one side, and other side should contain load resistors. So here we have to select the load resistors. Here I am considering this point A and B as my output point. So here is our circuit. For this circuit I am going to show you how to use the Norton's theorem. So here the initial step we have to do is we have to find the supply current IS. Then we have to find the equivalent resistor of the circuit. Now I am going to show you how to find the supply current here. To find the supply current for the particular circuit, we have to short out the load resistor. Here the load resistor is 40 ohm. I am considering this 40 ohm resistor as load resistors. Therefore, I am short out this point A and point B. Then here there are two voltage sources, 10 voltage battery and 20 voltage batteries are connected, and there are two resistors, 10 ohm and 20 ohm resistors are here. So here from the 10 voltage battery I am considering the current I1, and here 20 voltage battery the outgoing current I am considering as I2. Here I1 is coming from 10 voltage battery, here I2 is coming from 20 voltage battery. Then these two current will add together and will go through this path. According to the KCL, I am considering this node A. Here I1 and I2 are coming towards the node. Then these two current will add together and leave from this path. Therefore here in the short path the current will be equal to I1 plus I2. That will be equal to the supply current. Here IS, I am considering the supply current as IS, then IS will be equal to I1 plus I2. So now we have to find I1 and I2. So here I1 will be equal to, according to the Ohm's law, I1 will be equal to delta V over R. Here the V is supply voltage is, here the supply voltage is 10 voltage. So 10. The internal resistor, here this is the external resistor, we can consider as the internal resistor, or the resistor is 10 ohm. Therefore if we want the current flowing through this 10 voltage battery, we have to divide the voltage into the resistivity value. So 10 over R is 10. So I1 will be equal to 1 ampere. Then we need to find the I2. As the same way, here the I2 is flowing through the 20 voltage battery. So the voltage variation across the 20 voltage battery is, here V over R equal to delta V is 20 over the resistivity value is, here 20 ohm resistor is connected in series. Therefore we can consider this 20 ohm, this external resistor as the internal resistor. So 20 by 20 ohm, that is also equal to 1 ampere. Then now we can apply this value, or we can substitute this value for our equation number 1. Therefore IS will be equal to I1 is 1 ampere plus I2 is also 1 ampere, that is equal to 2 ampere. Then we have to find the RS. RS means the equivalent circuit of the the equivalent resistor of the circuit. So here to find the RS we have to do some more changes. Here we have to short out the voltage sources. Here I have short out these 10 voltage and 20 voltage batteries. Then we have to open the load resistor. Here the load resistor RL has been removed. Therefore here there is no current flowing path through this point A and point B. Now there are two resistors in between point A and point B. There are two resistors are in parallel form. These 10 ohm and 20 ohm resistors are in parallel in between point A and point B. So now I need the equivalent resistor in between point A and point B. So that would be equal to RS. Here 10 ohm and 20 ohm are in parallel form. So there is a equation to find the equivalent resistor when two resistors are connected in parallel form. Product of these two resistors into over sum of two resistors. So 200 over 30. So that will be equal to 6.67 ohm. 6.67 ohm. So we know the value of RS and IS. Here this is IS. So now we know the value of IS and RS. Then here for our Norton's equivalent circuit, here we have to place the RL here. Then our equivalent circuit will be like this. Then we have to do some more calculation. Here we have to find the voltage drop across VA and VB, and also we need to find the equivalent resistors here. Here again we have to find the equivalent resistor, the total equivalent resistor. So that will be equal to, here there are two resistors, RS and RL are in parallel form. Therefore the total equivalent resistor RT will be equal to RS into RL over RS plus RL. Then we have to substitute the value. Here for the RS 6.6 ohm, 67 ohm, for the RL 40 ohm. So if we solve this equation, we will get the value for the RT as 5.72 ohm. 5.72 ohm. Then final step we have to do is we have to find the voltage drop across point A and point B. So VAB will be equal to supply current IS into RT. IS into RT. Here we need the voltage drop across point A and point B, but here this is the symbol of current source. Here we can directly place the current source like this. Here IS, we know the current source IS 2 amperes and RT. RT is the equivalent resistors here. So if we substitute the values, we will get the answer for the VAB. So IS is 2 ampere and RT is 5.72 ohm. 5.72 ohm. So that will be equal to 11.44 voltage. 11.44 voltage. Now we can find the current. The final step, we know the value of VAB, we know the value of RT, then we can find the current I. I will be equal to V over R. So now again we can substitute for the V, here VAB, R mean RT. So now we know the value of VAB 11.44 voltage. For the RT we can substitute 5.72 ohm. So that will be equal to 0.286 amperes. 0.286 amperes. Norton's theorem summary. So here are some basic procedures for solving a circuit using Norton's theorem. Here there are 4 steps we have to do. The first step we have to do is we have to remove the load resistor RL. Then we have to find the equivalent resistor. Then the third step is we have to find the supply current. The final step is find the current flowing through the load resistor. We have to find the current flowing through the load resistor. So that is very basic and a very easy topic. So if you have any doubt, please comment on our comment box.